Hello friends, today I am going to discuss about surge protective devices connection for solar panels. In our previous videos, I already discussed about what is surge protective devices, why it is needed in an electrical power system, and what are the types of surge protective devices, all those things. And today I am going to discuss about how these surge protective devices are connected in a PV system and how it is going to protect the solar panel as well as the load from the surges created either externally or internally. Let us start with the DC side SPD connection. From the solar panel, we are going to take the outputs from plus and minus to the fuse boxes, and from the fuse box you are going to connect it to the SPD, and we are going to connect it to the isolator, and later it will go to the load. So this is the simple connection. So to represent that, I have shown here. So here they have not shown the fuse box. So directly taken from the plus and minus terminal of the panel to the isolator or a breaker, and in just parallel to that we have connected this SPD device. So what is going to happen in a normal operating condition, the voltages whatever you are obtaining here is not enough to trigger this SPD. Either it may be a metal oxide varistor, or you may have the GDT type or spark gap type. Okay. And here, so when the fault current happens or when the surge taken place either externally or internally, the surge current or the surge voltage is enough to make this device to conduct, so that the output will be given to the ground. So it will bypass the surge current to the ground. So this is how the function of this surge protective device is going to protect the load or the panel from any surges. So this is another configuration of the same device. So for higher current rating, and in the load side or from the inverter side, the output of the inverter, say I have taken three-phase inverter, the output of the inverter L1, L2, L3 and neutral is given to the SPD and through the breaker, and again it is connected just parallel to this the load or the breaker, and so whenever the normal operating condition is taking place, the current which is flowing through this is not enough to trigger this SPD, and when the surge current comes through this device, the surge current is given to the SPD, and the surge current is going to trigger the SPD, and the surge current will be bypassed to the ground. So it is depend upon the type of SPD what you are going to use. So based on that, the triggering will be taking place. So this is the wiring diagram, and this is how it is implemented in our site. So we have the solar panels, and this is a combiner box or a junction box or array box. So from here the connections are made. So we have the SPD here and the fuse box for plus terminal and fuse box for minus terminals, and we have the isolator here. So this is the panels we have in our site. Let us understand how the SPD is connected to this PV system. So here the terminals are taken from the panels, positive and negative terminals are taken from the panel, and it is going to the combiner box here. So this is the combiner box where I have the positive terminal fuse boxes here and the negative terminal fuse boxes here, and in just parallel to that I have the SPD connector here. So this positive terminal bus bar is connected to the positive of the SPD, and the negative terminal output of this fuse box is connected to the negative terminal here, and the output of this is connected to ground. You can see this yellow color wire which is connected to ground, and in just parallel to that the fuse box output is connected to the isolator, red color here for positive and black color here for negative, and output of this isolator is going to the battery bank, and from the battery bank it is going to the inverter, and from the inverter it is going to the load. So based upon the location the SPDs are going to be different. So this is for the DC side, and in the receiving end before battery there could be another DC surge protective device. After inverter we are going to have three phase or single phase AC SPDs, and just before the load again we are going to have another SPD to protect the sensitive load. So based upon the current rating and the voltage rating of the devices, so these SPDs are going to be different. So just before the load we may have the metal oxide varistor or TVS diodes, or when you are connecting near to the panel, so we may have the SPD like GDT type, or we may have metal oxide varistor type. So based upon the voltage ranges and the surge expected surge current. So these are the connections you can see here from the negative terminal. All the negative terminals from the panel is connected to this negative fuse box, and the output of this is going to the isolator. Also it is going to the SPD. So here you can see this bus bar, positive bus bar. One terminal is going to the isolator here, the red color wire, and the bus bar here shown, which is shown here, is connected to L plus of the SPD device. The specifications are given here. Imax is 40 kilo amperes and PV IN is 20 kilo amperes. Voltage up to 3.0 kilovolt. So these are the specifications given for this surge protective device. So this is the isolator connection. So the positive terminal of the fuse box is coming here, and the negative terminal of the fuse box also coming here, and the output of this will be going to the battery bank, as I said earlier. If the battery bank is far away from the panels, then we may have the receiving end one SPD as well. If it is close or a bit just below 10 meters, then we can have a direct connections. So based upon the distance, we need to increase the SPDs. So this is the overall connection of the solar panel with SPDs and fuse boxes and isolators. And also we can have a different earthing system for different systems. So if you have TNS earthing or TNC earthing and TT earthing in the load side, so that is after our inverters. So based on the earthing system, the configuration also differs. So for the TNS earthing, so we have the line and neutral connected to the SPD as input, and the output terminal is connected to the protective earth. And for TNC, that is earth, neutral and combined earthing system, so the line is taken as input, and the output is connected to PEN, protective earth and neutral wire. And for TT, again we have the line conductor and neutral conductor taken as input, and the output will be connected to the PEN wire like this. So this is for different earthing system for single phase. And for three phase it is shown like here. So we have L1, L2, L3 and neutral. All these four wires are connected as a input, and then the output is connected to protective earth. So in case of surge voltage in any one of the line or all among the lines, then the SPD will trigger and bypass the surge current to the PE wire, and it will go to the earth. So TNC again L1, L2, L3, and this is acting as an input, and the output will be connected to PEN. And TT mechanism, again we have L1, L2, L3, neutral is connected as input, the output is connected to PE conductor. So these are the different connections at the AC side. Hope it is clear, and that's it about the SPD, surge protective devices, and we have discussed all about the surge protective device. If you have any doubt, please let me know. If I know, I will share with you. Thank you. Thank you so much.